Hello, everyone, and welcome to today's webinar. Delighted to welcome you here today. My name is Elisa Sklar. I'm the VP of Marketing for GIS Planning. Today, we are going to be talking about data. We're going to be hearing from a number of different guest presenters and looking at the strategic use of economic development data for investment attraction and business retention. And with that, I would like to introduce everyone we have on with us today. We've got Gary Menger from Applied Geographic Solutions, AGS. We've got Pankaj Mathur from Data Axle, formerly known as Infogroup USA. Paul Linares from Emsi, and our own Jeff Suneson from GIS Planning. Hello, everybody.
Hello.
Good morning.
Hi, good morning.
Hi, guys.
Thank you all for joining us today. I am really looking forward to this conversation, and I guess the way we're going to run things today is I'm going to hand this off to each of you one at a time. We're going to go with the order on the screen here. Each of you has prepared a presentation for our attendees today to talk about the kinds of data that you've got, where, how that's collected, how it's refined, and how it gets used. We'll talk about that as well, how it gets used in our GIS planning tools. And then at the end, we're going to bring everybody back for some discussion and to address any questions or comments that people have put in on the screen. So with that, I'm going to turn this over to you, Gary. Now you will get a little box on your screen that invites you to share your screen. You see that?
I do. And hopefully, can you see?
Yeah, we can see your slide deck.
Our little title screen?
Yep,
Perfect.
that's perfect.
All right.
Thanks. I'm going to mute myself in the meantime so we don't get any feedback, and we'll join back with our webcams at the end for the Q&A.
Great. Well, thank you for inviting me, Alyssa. And this is actually a very special year for AGS. We are 25 years old this month, and we've actually been working with GIS planning since before the turn of the millennium. I think we were one of the first data providers that they brought on board, and we've been with them ever since. So AGS basically is primarily a data supplier, small area geography, so block group, census block, zip+4, and so forth. We have about 35,000 variables available for every single neighborhood in the United States that we update twice a year. Our website's pretty comprehensive, so I don't want to bore you with the details. It's more of a bedtime reading if you've got insomnia. You can read all of our methodology and content documents on our website, but basically we are concerned with answering a bunch of questions about neighborhoods. Who lives here? Who works here? Where do they work? What kind of housing do they live in? Where do they buy things? What do they buy? What keeps them up at night? That's my kind of catch-all for our crime data, our weather risk, wildfire risk, and so forth. And then how do they think and act as consumers? And the last one on this is how healthy are they? So we carry a lot of very detailed estimates of medical demand by condition, so extremely detailed. I don't want to bore you with that stuff. You can look it up. You can get in touch with me and we can talk about it. But for today, I really wanted to talk about what I would call data in uncertain times. And basically, about 1 in 10 people in the United States moves every year. And yet when we look at data over several years, we find that most neighborhoods don't really change all that much. They change very slowly. When you get a new development, it can often take a decade to fully develop. Existing neighborhoods, as they transition, it tends to be over very long periods of time. I would refer to this as basically being, demographics are sticky. Think about some of the towns in Michigan and Ohio that were heavily automotive dependent in the 60s. You could see that there was the beginnings of stress on those communities, but it took several decades for it to really come about. On the flip side, we have what I would call black swan events, things like Hurricane Katrina. So when that hit, I literally had telephone calls within days saying, how come your reports still show all these people in New Orleans? You know, didn't we know that they'd left? Those kinds of catastrophic shifts. So today I wanted to talk about how we responded on a couple of fronts to the COVID-19 crisis. And we very quickly realized that we had a problem. We release data twice a year. Once is for January 1, the other is for July 1. So we were kind of mid update cycle and looking at our unemployment numbers, which had basically been the best that they've been in decades, and looking at it saying, can we release data that it admittedly is backdated to January 1 and would have been reasonably good for that point in time when you're seeing millions of new unemployed. So what we decided to do was to offer weekly small area unemployment estimates, and we adapted our existing models. Our models are really designed to take annual and semi-annual data sets and work with them. So we started to use the weekly new unemployment claims and the continued unemployment claims coming out of the Department of Labor. And over time, we kind of adjusted these models. So every week I came out with a new methodology statement as we kind of worked through it. But what I wanted to talk about was that our biggest problem was that the data sources really just didn't add up. There were mathematical inconsistencies in this that caused me to seriously question their validity every week. And what we kind of discovered as we worked our way through it is so every week the unemployment offices of each state basically compile statistics and they send them on to the federal government. And this would be, you would think, a good measure of new unemployment. The problem is that it isn't. We had entire state systems crashing. We had local offices closed. We had state employees staying at home. And so in short, what happened was that a very stable data collection system basically came crashing down around us. Here is the map of what the unemployment looked like by county in early 2020. And then I'll show you how this is a monthly map that shows the change over time. And you will see some very strange things. You'll see Kansas pop up here, right there, with high unemployment. You'll see other states come and go on the high unemployment. So what we basically realized is that they aren't counting new unemployment claims. They're counting completed new unemployment claims. And that's actually different. And what I wanted to kind of address this morning, because I don't really have a lot of time, is this issue of the fact that often as not, we think that we're measuring something, but we're really measuring surrogates for it. Most of the time, those surrogates work really well, but when you really need the data to work for you, that's when we find that it doesn't necessarily work, that the systems which are underpinning that were designed for different purposes. And so we can often find that our data, our gauges, whatever it is that we're using, will tend to go haywire exactly when we want to look at them in the first place. So that's kind of the one lesson I really want people to understand is often as not, with our 35,000 variables, almost none of them measure exactly what somebody really wants to be measuring. And usually it's because we don't have a way to measure it. So we tend to work with surrogate measures, which generally work fine. But my caution to people is when things go a little bit haywire, you need to really look at the data that you're using and why it was collected, because the why it was collected can become very important if it's not the same as what you're doing with the data. So on that one, I'll kind of leave the unemployment alone and turn to the second one, which is income. And with unemployment rates basically going up by a factor of 4 to 5 in most areas, we immediately said, well, this has to affect our income estimates. And you would think that it would. And in fact, what I've done here is here's the cumulative distribution of household income 2019 and 2020. And again, I'll go back to the kind of dashboards that everyone's so into these days. You'd look at that on your screen and go, oh yeah, that looks pretty much the same. And it is, except for the fact that when you're talking about something like income, those tiny deviations there are very substantial. Our median incomes really did not change all that much. When you started to look at it, what we discovered was, of course, that low-income households were getting supplements. They were getting checks in the mail and things like that, unemployment insurance supplements that actually raised a lot of households' income last year. The upper end, they generally do well regardless because they have the resources to change strategy and so forth. And so what happened here when you look at the individual income groups is that we have this what is really a substantial change. In 1 year, these distributions changed more than they changed in the last 5 years. And what we're finding is that the low income groups have kind of diminished a little bit. The middle income groups have increased, which basically means that they're kind of stuck in the middle here, and the upper income groups have increased, meaning that people at the upper end of the income tail actually did very well. At the low end of the income tail did very well, and in the middle they kind of got squeezed out. So we actually had people very surprised at our income numbers, simply because the expectation was that incomes had gone through the floor when in fact they really haven't. So what it did though was flatten that income curve. One last point that I'll make very briefly is we've seen a lot of stuff about Manhattan and San Francisco and so forth being abandoned. The evidence that's being cited is mobile phone locations. And what I would caution people is it's really too early to tell. We took a look at what percentage of households in some of these cities own second properties, and Manhattan is one of the highest in the country. So what I think is happening is that people have simply run away to their summer home up in Maine or to their place in Florida, whatever it is. What we don't know is whether they'll come back. I think that they probably will, but I think it's really important to avoid those kinds of generalizations that you're reading about, and just kind of think through some of the data that's underneath that you can bring to bear at a problem to understand it. So, kind of in summary, I'll just reiterate the notion that it's really important to distinguish between what we think we're measuring and what we're actually measuring. And in this day and age where everyone's got their dashboards on their corporate websites, you really have to kind of look underneath to see what those gauges are actually showing you, because often as not, it's not what you think it's showing you. So if any of this is interesting to you, we do offer a weekly newsletter that comes out by email and gets reposted on LinkedIn. So drop me a line and sign up if you like, and hopefully there will be some questions, and we'll end it at that point.
Thank you, Gary. Okay, lots to think about, and addressing certainly some of the elements that have been making headlines over the course of the pandemic. So really some interesting stuff to chat about. I'm going to pass this on to the other presenters, and then from there we will take the questions at the end. We do have a number of questions that have come up. And Pankaj, just before you get started, a reminder to everyone that if you have questions, we invite you to put them in the questions field in the GoToWebinar control panel.
All right, Lisa, thank you so much. Can you guys see my screen?
We see your desktop, yes. There we go. Now we see your presentation.
All right. Hi, everyone. My name is Pankaj. I am part of Data Axle team. That's the recently rebranded name. Many of you who have been in the industry might know us by the name Infogroup. Prior to that, we were Info USA. Couple of weeks back, I actually sat on a presentation by Stevie from GIS Planning. She did an amazing job of highlighting different data sets which are integrated onto the platform. And it was amazing to see the diversity of data sets that are available that you guys are using for your planning, forecasting, trend analysis. So our contribution to that data, the solution set, is business data. I understand many of you use the active businesses as sort of a pulse point to check how is the economy doing, where it is headed. So we're going to talk a little bit more about business data for next 4 or 5 slides. So we've been doing this for a fairly long time, getting close to our 50th anniversary. So the universe today is very different compared to when we started back in 1972. So we have redefined ourselves several times. And in terms of application, beyond GIS application, our data also get deployed on a fairly large scale for commercial real estate, business intelligence tools, targeting activities like display ads, social media campaign, connected TV. So think of it like an extension of a QC. The millions of eyeballs that are using our data on local search properties, it kind of essentially goes one record at a time to see if the record is correct or not. And that's a benefit that gets extended to all of you. So like just the industries where we have found to stay relevant application of our data, this slide should not be a surprise to anyone who's been using GIS planning tools. If I could rephrase the bullet points on this slide, it essentially represents the IP of Data Axle. So it establishes how we are able to leverage technology. We have a data science team that looks at billions of signals that are coming into our funnel from the left-hand side. And it's humanly impossible for anyone to look at those things manually. So that's why we use state-of-the-art data science technology. And then it's the optimum combination of how much technology we use and how much human validation we do. So even in 2021, we still conduct 25 million phone interviews. What that helps us figure out the component that technology cannot get to. So let me just give you a quick example. So we got a feed from, say, a new business filing for John Doe LLC with a PO box number or a home-based address. And all we got is a phone number, nothing else. We have no clue what they do. Is it a valid business? Yes, as per IRS, Chamber of Commerce, it is a valid business. But in your environment, it is not of much value because we don't know what exactly they do, where are they located. So the phone interview comes as a next logical step. When we dial the phone and connect with John Doe LLC, John Doe LLC could tell us that he's a franchisee of Subway, in which case we got the specificity of SIC code. And we also understand Subway is part of a larger corporate chain, so we could create the linkage. Or he could tell us that he's a work from home plumber, in which case we will just tag the home-based address as a work from home indicator. So applications like local search would not use that for turn-by-turn driving directions. But for GIS planning tool, you could still incorporate that. And then we will also ask how many employees work there and few other questions that are verified on the phone interview. So a lot of these attributes are widely used on GIS planning, Zoom Prospector tool. I would just point out the few significant ones, although the total list is about 400 attribute long. Employee size, that's the direct benefit of that massive human validation that we do. Corporate linkage is another one. Physical address, because it has been phone verified, oftentimes it is incomplete, non-standardized, suite number is missing, specificity of SIC code. Contact names, a fair amount of trend and analysis do get down to the part where there is a call to action and an outreach might be required. So contact name titles is huge. All that is the direct benefit of the phone validation that we do. So back in 1972, when we started, it was probably handwritten Rolodex cards. But fast forward to 2021, our entire database is hosted on a cloud, Amazon cloud. And we serve data through APIs, and we track state-of-the-art data science to track of billions of signals that come our way and also do human validation on top of it. So this is a Forrester exercise that was done, I think, in 2018, where we figured right on top of all of our peers. I mean, these are all branded entities. They're doing good stuff. So it's kind of a source of pride for us that we figured relatively on the top. The new one is coming out. In next few weeks, we expect to be again in the same place, the near very top, if not the top. This is also a testament to all the investments we have made in terms of technology, re-engineering our compilation process, incorporating new feeds that became available over time, which wasn't the case a decade back. So this is kind of a reflection of everything that we have done across the company. Then let's talk a little bit about business. And this is the very last slide I have, so nothing more to come after this. So few of the challenges while we looked at sourcing, like sourcing could be a business filing with a county clerk, it could be a utility connect or disconnect, it could be a social media where we could have picked up. One of the challenges that we grapple with is there is no definition of business, especially if you look at the vast number of industries and the clients we serve. So in this particular case, you could say a brick and mortar needs to be a business. It needs to have an address, but then what about the ATM machines? Like in this city like New York, where the ATM machine is embedded in the center of a wall between two blocks, it doesn't have an address, doesn't even have a phone number, and it doesn't really have a name to go with, except for the logo that may be printed on top of it. Then does it needs to have a physical address? What about a business like 800 Flower, right? All you need is a telephone number. Is the telephone number that important for a gas station where you typically are likely to drive? So these are the challenges that get in our way of even defining what a business is. So that's like the starting step number one, and we got huge challenges there. Then if we can, and we have come up with our own definition of what we think is a business, it works remarkably well across multiple industries. Then we bump into a second hurdle, which is there is a lack of consensus on what constitutes the truth. So there is a notion that there is a truth out there and it's just a matter of getting to it. Like a simple example, if I were to ask this set of audiences, what should be the primary SIC code for GIS planning, you would probably get as many answers as number of attendees. When you ask something which is somewhat more controversial, like a fast food joint, what the cuisine code needs to be for Burger King or Taco Bell, again, it kind of delves into a gray area. So there is only thing we need to admit is that there is a lack of consensus, but that's not to say that we cannot normalize and we cannot compile data. So we have come up with rules. We have come up with some sort of a consensus algorithm that that holds its logic well across multiple applications. Then there are operational constraints. I think this will be of particular interest to these audiences. I'm going to pick on a few examples just to highlight this. So there are, at a very high level, there are three sets of challenges in this bucket. So one is so we compiled data. It covers about 11,000 odd categories. Each of these categories is a 6-digit defined code in our database. There are a handful of categories like think of DMV, think of movie theaters that will never answer the phone. So those categories warrant certain exceptions. That means we will not hold the criteria of phone validation and 4 interviews for these categories. The good part is the number of such categories are far and few, and there are reliable online sources available where we could capture this data without compromising the integrity of coverage or quality. The second set would be a set of categories. Think of like emergency responders, police stations, fire station, abuse shelters. These categories we ourselves do not call because it is the right thing to do. We would not want to call an emergency responder service just trying to validate their phone number or certain basic information. Again, the good part is the categories like this are far and few, and there is a very reliable sources available online and offline where we could capture this data. The third set of hurdles is what I have heard enough examples from Jeff. So I want to address this, take a minute or two on this. So think about what happens. So it works like a charm when we dial a number and talk to a John Doe LLC because we could capture all that information. But what happens when you dial into a business like San Francisco Airport? So there the person answering has a common sense challenge that it is difficult to define what constitutes San Francisco Airport as a business. I mean, it literally covers half the city of Burlingame and Millbrae. There are cargo hangars, there are maintenance hangars, there are airline offices, there are food courts, souvenir shops. So what constitutes a business in this case is an iffy. What constitutes employment or the headcount becomes even a bigger variable. But then if you're doing city planning for city of Millbrae and San Bruno, this is a big problem that you need to tackle. So the good part is, while you may not agree with our version of what we have provided as employment count, the good part is that if the disagreement is at a record level, or at a category level or at a chain level, there are attributes available within our data set where you could do a one-time correction and not have to live with the disagreement. That means if San Francisco Airport is important for your analysis, you probably would have some perspective, including historical experience, what the employment count needs to be. So there are ways where you can override this information. Our data is structured in that manner. So it kind of gets more into geeky data stuff. So I would not want to go deeper into that. But if this is an area of interest, by all means, reach out to Jeff. Happy to have a conversation how we can help solve this problem. And then lastly, there was, just like any other business, we also hit a lot of road bumps like any other business because of the lockdown. And the good news there is those were temporary. Those are well behind us. So we're getting to a point where it seems like business as usual. People are answering their phone calls. We are validating. So you should not see any decline in terms of coverage or depth of data. Alyssa, this is all I have.
Excellent. Thank you so much. Again, we're getting some great questions come in. I just want to remind everyone that if you have questions, you're welcome to put those in the questions field in the right-hand side of your screen. Paul, I am going to turn this over to you.
Thank you, Alyssa. Looking for, okay, here's the bottom. Let's see. Can you see my screen?
We can see it, but it's really small.
Okay, I think I know what's going on here.
No, it's probably this presenter display. Yeah, you just could swap displays. Now we see your desktop.
Okay, cool. Let me move this here.
Perfect, yeah.
Let me move this here. Okay, cool.
Thank you.
No, thank you, actually. Okay, so first, thank you for having me here, Lisa. Since I started in Emsi in 2012, I saw firsthand how Emsi grew, right? And become one of the leading providers in labor market information for different markets, for higher education, economic workforce development, people analytics, site selection, real estate. But what is Emsi's goal here? Emsi is try to connect people, education, and employers, basically the three big players in the labor market. How we do that is providing reliable and consistent information through time. I'm planning to talk a little bit about the history of Emsi, how our data is integrated with other platforms, how we collect data, how we process the data, how frequently we release the data, how the pandemic affect our process, and where are we going from here. So the founders of Emsi started Emsi as building an economic impact study for community college. When they started building this model, they needed a lot of information from different sources, mostly government sources, BLS, Census, National Center for Education and Statistics. And these data need to be analyzed, right, in order to create this model. The data that they needed was understand industry as a group of companies that provides the same good of services or similar good of services, and occupations, that jobs that are very similar. But one thing that they found is that even this data came from the same source, for example, BLS, this data doesn't connect well, right? So in one source, we found wages or earnings for industry, and the other for occupation. Yeah, that's true that BLS provide a staffing pattern for connecting industry and occupation, but at national level. What about regional level? What about MSA? What about counties? What about states, right? So the founder, they said, okay, first we need to centralize all of this data that we needed and normalize this data, meaning create a standard geographies for this data and make this data talk about them, right? So that's how one software tool that we have analyzed was built. Time fly, and then from analysts, we get developer. Developer is a software tool that is more focused on economic and workforce development. So either analyst or developer use three groups of data. One is what we call traditional labor market, which is basically government data. And as you see, this government data is releasing different time frames. One is some is monthly basis, quarterly, or annual. What we do is compress all this data, we gather all this data, and we release our data in quarterly basis, right? So, but this labor market information, this traditional labor market information is not as granular as sometimes we need to. So, for example, if we want to talk about skills, if we want to talk about job titles, labor market government data is not very useful. So Emsi start collecting data for the demand and the supply side of the labor market, right? So in this case, job posting. Job posting is basically company data that this company is sending a signal to the market and saying we're requesting a particular type of people with a particular set of skills, and that's part of the demand of the market, right? So for the other side of the equation, for the supply side, we start collecting profiles data. We have more than 100 million profiles for US and a lot of more millions for global for profiles at global level. In this particular case, what we're seeing here is what the individuals, what are the skills that the market is providing, right? Is the supply side, as I said. So what happened is Emsi grab all this data and create reports with this data. So we gather, we clean it, and we process the data, and we display the data or we update our data in quarterly basis, right? So we create some reports at the industry occupation and educational level. We also provide input-output models, meaning regional impacts. So if a company comes to your region or a company leaving your region, how much money are you going to get or lose, or how many jobs are you going to get or lose for that effect? So in analyst or developer, we display the data in a tabular way or in maps. For maps, we use a map box. We use map box to render the data, and we use map tiler just to make it a little bit fancier, right? So we show satellite views, or we can display roads. What else we do? We not only gather the data, cleaning, process, and display the data, we also modeling the data. So we use some machine learning algorithm for skills, and for job posting, we use visualization like a dashboard. And also for posting, we get compensation. So we know the government data provides earnings and wages, but it's 1 year behind or 2 quarters behind. And sometimes when you talk about job titles, the compensation from posting is more appealing for some of our clients. For profiles, we get pathways, for example. We're modeling the profiles just to get a sense of probability. What is the probability to move from one job to another when you started in, for example, if you graduate as an economist, what will be the probability to start a particular job in your career, and what will be your last job or your most current job that you're going to hold? Skills in Emsi is basically an intersection between posting and profile. It's the common language between these two. And from this common language, we create this cluster analysis, these skill shapes, right? So for example, I am data scientist, but what about if I want to be a web designer in the next year? So how my list of skills align with web designer? What other skills I need? How close or far away I am from this occupation, this job title? In terms of career pathways, we display pathways, as I mentioned, we use Sankey's graph, but here the beauty of Pathways, you can slice and dice the data in any way, in many ways, right? So, for example, you want to see what after you have your latest degree, not necessarily your highest degree, but your latest degree, and what is the first job that you get, or you can start from the bottom, right? What are the from your current job? What was your first job, right? So, how we deliver our data. Sometimes a client only wants a request a data pool, so we provide flat files, either CSV, TXT, Parquet, S3 buckets, you name it. Also, sometimes we provide consulting services for more analytical and in-depth view of the data. Another clients connect, they connect their applications through API or APIs. Recently, also we are offering snowflakes. So basically, if you work in Tableau, we can connect Tableau directly to a snowflake that we put our data there. So it's kind of I found it very neat. Also, as analyst or developer, we offer software solutions. What decisions we can influence, right? So depends on the data sets, even they are very similar, at the same time are very different. So for the traditional labor market, we say, what is the size of the supply or demand for this particular occupation? How much of this occupation? What is the median earning for this particular occupation? In terms of job posting, is we can say how my job post competes against another job post for different companies, right? It's competitive in terms of in salary or in terms of the skills for the same position. In terms of profile, for example, the talent agencies say we are targeting the correct region. There is enough talent in this particular region. So one way that our clients use our data, for example, in here, we provide traditional labor market data, and GIS Planning display our data in a very neat way with mixing with maps, and I really like this one. Well, everything was fine until last year, right? So in the last year, we noticed that even our pipeline was not affected, but our predictions were affected, right? Population, number of jobs were way off. And people start asking, okay, we know that you use time series to model in these numbers, but right now I need some more reliable information. So in that way, we went to postings. Posting is quote unquote real-time data. We get job posting every day. So what we did is we provide to our clients a view of the last 30 days in the job postings market, in the job posting for their regions, for their sector. And also we said it's good if you want to measure the short-term effects for companies closing their doors or people leaving the region, you can use input-output model, the input-output model, right? Also, we say to our clients, you need to check for unemployment insurance claims. So these changes, when you mix with the input-output, it's going to give you a better sense of what's going on in your region. How long, well, not how long, how deep will be the effect in your region. Now what we're doing right now, one thing that we still are working on is trying to create a common language between our clients, and that's the reason we open our job title library and the skills library. We have more than 75,000 job titles. That these 75,000 job titles came from more than 20 million job titles directly from the job postings, right? We have more than 3,000 skills that we update every week. Also, we offer skills categories. Well, we know that 3,000 skills is a lot, so we compress these 3,000 skills in 56 groups. Also, right now we're offering the census tract information beside of the zip code, because zip code is not a geographic location data, or geographic location. It doesn't map very well, doesn't with MSAs or counties. So zip codes could change faster than census tract or how the census define a region. Also, we present talent benchmark. Instead of visiting multiple APIs in Emsi, you can visit this API and get data for supply, demand, and compensation. And currently, we're working also on professional migration, right? So ACS and IRS, they lag in 1 or 2 years to display migration. We're currently using our data. We can show at least in the last year how people migrate from one region to another. But that's all I have. Thank you, Lisa.
Thank you very much, Paul. I appreciate that. And I'm going to pass this over now to you, Jeff, so you can walk us through other sources of data that we use and how this all comes together in GIS.
Thank you so much. Thanks, Elisa. And
Yeah.
let me just make sure, can you see my screen? You should see the Idaho Prospector site.
I can, yeah.
Great. Yeah, so what I want to touch on here is how we incorporate this data from everyone that's attending this webinar here and bring it into our suite of tools, as well as some of the other unique things we can do that are specific to our clients, and just even through some other data providers. So what you should see on my screen right here is the Idaho Prospector. Just click on one of these listings here so we can bring up our different reports. And what's nice here is I'm going to kind of just highlight the different reports as they go back to Applied Geographics, to Infogroup, and to Emsi, because those are all reports that come up when you select a property or a community here. So thinking, in terms of Emsi initially here, when we click on the occupation tab, this data is all being sourced from Emsi, and so we're looking at the compensation. So we have it hourly and annually, and we can break it down into these subcategories here. The nice thing about what we can do is we can put a spatial context on it. So initially we're looking at this on a 10-mile radius, but we might want to see where this varies. Now with the occupation data from Emsi, this is at the zip code level, so it's not going to be super detailed, but we can get a greater sense of if there's differences in pay throughout the region. So if I turn on something like Computer and Information Systems Managers, you can see it loads up that heat map here. And if I zoom out a little bit, we can get an idea where pay and compensation may be higher or lower within the area. And so we can see, and one of the things we do is we do resample this data based on the zoom extent, and we'll show it at different levels of detail. But we can also then see here, if we were to look in some of these outlying areas, that there are some differences in compensation there. With the Emsi data, we're also looking at it. We look at it annually. We can also pull it in hourly, but we also are able to bring in their job totals here as well. And then you're able to also look at these by NAICS or occupation here, which is the categories that they come up with. The other thing that's important to note about all our reports in here is that you can change those from 1 to 60 miles or 1 to 60-minute drive time. Updates all the parameters that you're seeing in here and reports the data back out that way. Also, you can do these by community, and that can either be by city, county, a region that the state has defined or the client's defined, as well as by MSA. And also, one thing to point out, and I'll just mention in this first one, is all these tools are meant to be shared, and they can be exported to PDF, they can be printed, you can share the URL and bring users back. So the idea here is you really want to let this data be used by people on the site. Now, the next three tabs, the demographics, labor force, and consumer spending, this data comes from Applied Geographic Solutions. Just an example of that, and I know Gary spoke to some of the things that they do, but we bring in these three different reports from them. Again, just like the other reports, we can look at that information and we can turn on that heat map. Now with this, we actually get the detail down to the block group level. So right now we're looking at the zip code, but if I zoom in on this location, we can now see this at the block group level. And it lets us see the data a little bit differently. We can see, okay, within a 10-mile radius, this is the amount per household being spent or total aggregate, but where is maybe that the highest? So we can see that here. We can even click on one of those block groups and bring up the total value, and that would tell us within this block group how much money is being spent. And again, that's across all these reports. You can do these different, what we call heat maps on the system. So it augments both that radius value, and then you're able to see those concentrations within. The next data set here is the business data, which comes from Infogroup, a data axle. And again, we update this nightly now against their API, as Pankaj mentioned. And this is a really rich data set. It's it's one that's updated the most frequently against our source. And there's different ways to interrogate this data. So we can increase our radius, maybe show a 10-mile radius, and it will look a little busier here. We're picking up all these properties in Boise, but we're also now looking at the data here and we're aggregating the totals, the sales totals, and the total number of employees. We can drill down into that data. We can then now see within these categories, what are those totals? Then we can even drill even further and get those specific business names and pull those in. And this will highlight those at that point and just isolate those listings. Now, if I go back here, another thing we can do with that business data is we can, go in here and we can decide we only want to show certain types. Maybe we want to see only our larger employers. So we can put something in like that, and it's going to show us those results that match that query that we put in. So again, that's bringing all those sources in from our guests today. We have some other sources of data that we bring in here. Another one that all our clients get is our talent data. That comes from the National Centers of Education Statistics. This is looking at the number of graduates by program, by university, and by graduation level. So if you are doing outreach to young educated individuals looking to enter the job market, you can see what categories those are in. So if I'm looking for engineers, I can then drill down into maybe civil engineers, and I can see where those are that were either graduates, and I can see which university that they were graduating from. So that lets me know where I might reach out. The city and county profile, these are our infographics, and they do source heavily back to the Applied Geographic Solutions data, but they also incorporate some of our own GIS analysis at GIS Planning. Just to highlight a couple of those, so with the infographic, one of the nice things here is we can go through back in time. We can look at this in more of telling a story and pulling out those top level bits of data. Things like job growth, population growth. But then here's where some of that analysis comes in by GIS Planning. We actually go in and we determine how many colleges are within a community or within 12 miles. We do the same thing down here in the transportation section. We use our GIS analysis to determine if it's served by an airport or how many are within 50 miles, different things like that. So the infographic really is kind of a mesh up of these different sources. And the same thing happens with the county profile. We're just looking at it by county. Now for our clients, these are available, these infographics are available for any community. So whether it be a city, county, state, metro, we can also look at the data in this way. Now, the other piece that we have here is there's some other sources of data that we like to bring into our client applications. So I'm going to click over here to another site. And one of them is that GIS data. Now, we're looking at the Apopka Growth Alliance site, and this is a client that provided some of their own data. And in this instance, they actually sent us the data. We host the data naturally on our end. So they gave us some things, under here, under local data, we have, City of Apopka, which is highlighted here. We have the Apopka zoning, which shows here. And things like this, as we zoom in, we'll start to see the zoning label. But then these other layers, like the schools, let me go back in here and turn off the zoning real quick. I can click on these schools and I can get the actual information. Again, we are not creating this information for them. They gave us this information, so it can populate with whatever they want to show. So in this data set, they wanted to show the school grade, the name, the address, and then here is a link back to that school. And so we can do that, whatever that source of data is. The other thing we can do, and I'm just going to go over to another site here, is we can connect to ArcGIS server services. So if you're an organization that has a service running, you can publish that out and we can consume that naturally, as you're seeing over here in the Beacon Council website. The beauty of the API and pulling it in from ArcGIS server is any changes the client makes is going to be reflected real time on the site here. So I can see their zoning showing here. Again, when that zoning populates here, this is 100% coming from the client. There's nothing in here that we have locally, so it is dynamic. And they have some other layers here like land use, which we can bring in. They have their parcel data, which we can zoom up. I didn't mean to select property there. We'll go back over here to but you can see the parcel lines come in here actually after I did that. And then the other nice thing about when we consume that is it displays however the client has designed that. So if they want the parcels to look a certain way like they did here, they simply control that on their end. So that's another example. Now, another thing we do at GIS Planning is we do maintain a whole series of our own GIS layers. So I'm just going to go back here to the Beacon Council site. We maintain broadband data for the entire country. And when I say the entire country, if I zoom out here, you can see I can show these layers that we have nationally. And the way we do these things, we can do them fast. I do think we're one of the few sites that with this amount of data, we're able to show it and plot it without, slow load times. We also have things like education data. Some of this was from them, but we also have actually the post-secondary education that comes from us. So technical schools, universities and colleges. We also have environmental data, whether it be wetlands, flood zones, that data is all in there. Most of these sources of data are federally sourced. I'm not going to go through all of them here, but if you're ever curious about any of our layers, I always recommend going over to our help center. Our help center lists all that out and it gives the different sources of that. Now, most of our clients have the help up here in the top right corner. For some reason, this client does, but if I go back to the Apopka site here, I can click on this here. And it's just a great way to find that. So I can look up data sources and I can see here, maybe I want to look at my GIS map layer sources and we call that out. So we're very open with where that data is coming from. We have links back to it, also with the Applied Geographic Solutions, Emsi data, those are all referenced in the Help Center as well. Now we have some other instances here of clients that have some unique reports that they want. And for this, we're going to go ahead and click over. Well, actually, I want to show one other thing here on Carolina's commercial, just things like even like parcels data, we're able to plot that data and make it look good, make it run really fast. You can see here, it's virtually, seamless as I'm scrolling on that. So it really doesn't matter the level of data you're providing us, we're able to plot that and make it work fast, I guess what I'm trying to say. But then back over here to our client here in South Carolina, they had a unique set of data that they had gone out to Site Selection Group, which was a labor study. And they really wanted to incorporate that into the system. And that is something we can absolutely do. It does require you to provide the source. But here's a great example of that labor force study. And again, it's available for every location within their county. So if I change to Clarendon County, it's just going to basically now populate that same labor force study for them. It can be heat mapped as well. They have this down at the block group level, so we can look at these results that way. And then just to look at this, they have like available industrial workforce. They have all these descriptions in here. Really, if you have the data, we can bring it into our platform here. And then finally, I do want to show one of the data sets that we provide at a premium level, which is our foreign direct investment data. We get this through our sister company, FDI. We update this data quarterly into the system. And what you're seeing here, we're on the state of Florida site that subscribes to this. And since they subscribe, they have this foreign direct investment option here. Now, one of the nice things we can do is we could change our location. I decided to just show for all of Florida. and we can see the total number of projects. And then we also include not only foreign investment, we do drop in the US domestic investment as well. Now I can sort this by county or by sector. It's going to show a little bit different. Let's go back to country. And so I can see the top 3 countries are the United Kingdom, Germany, and France. And if I want to drill into one of these, I can simply open that up and I can see the different categories that they're in. And if I'm interested in something, I can see transportation and warehouse. This will then show me those individual projects. And we're also able to see the total number of jobs each of those projects provided, as well as the total investment. This data does go back 7 years, so it does include some, ongoing projects and the new projects on the horizon here. The other thing we can do with this is we can plot these out. If you want to see where most of these investments from France are happening, you can turn on that heat map here. It's a little hard to see here because we're plotting this at the community level, but you can see then where there's concentrations. And you can see over here in Miami, there's quite a few different projects in here. So I can see the total investment from France. Here is that total investment value here. And that's in thousands, by the way. And then it looks a little more impressive if I just zoom out here and let's say we show all of the domestic investment here. Let that load. So then we can see where there's a concentration here over in Jacksonville, Orlando, and over here in Tampa. So again, this is a really powerful data set that lets you know where people are coming in and investing from, whether it be domestic or internationally. We don't really have any hot links back to these projects, but you could easily Google these, find out more information about some of these projects in the area. So I think that shows a really good picture of what we can do over at GIS Planning with this data. I know we're a little bit short on time and I want there to be time for questions, so I'm going to go ahead and wrap it up. Elisa, I'll turn it back over to you.
Thank you. You could just leave your screen up, actually, if you don't mind, Jeff, just in case there's any questions related to that. We do have a number of questions that have come in. Pankaj, let's start with you. Questions about whether you are tracking home-based and/or private businesses.
Yes, the short answer to both questions is yes. We do not distinguish between public and private businesses, although information is easy to come by for public companies.
Right.
Like the example I used of John Doe LLC, during the phone validation, if it turns out it's a work from home, say a plumber working out of a van, we do have a process in place where we tag addresses or businesses that are work from home.
Excellent. Okay, great. Thank you. Gary, does AGS provide multivariant data sets? So age or income distribution within an ethnicity category, for example?
Most of our users don't want to get into that level of detail. Certainly on a custom basis, we can do it. 20 odd years ago, we used to provide income by age, by race, by Hispanic origin, and so forth. And what we discovered was that very, very few people wanted it. But if somebody wants it on a custom basis for an area, we can easily do that by going back to some of the census materials that are around. But yeah, it can be done. Typically, my comments to people are that if you take the income distribution and you take an age distribution, you're not going to find anything surprising for 99% of areas.
Okay, interesting. Okay, thank you. Let's see. Is anyone tracking homeless populations or people who aren't documented?
Let me address that on the undocumented issue. The Census Bureau historically has not distinguished between the two. That said, we know that undercounts in areas which are have large percentages of undocumented people tend to be very low. The 2010 census, we obviously don't have the data for the 2020 census, but for the 2010 census, the underreporting estimates for some block groups were as high as 50%. we don't track it separately. You'll hear the figure 12 million bandied about, but it doesn't take a lot of math to figure out that it's a lot higher than that.
Okay.
On the homeless side, that's really dynamic. It's very hard to track. There are a lot of communities now that actually do those sorts of surveys annually. And so Southern California, Los Angeles does it, Santa Monica, and so forth. And those numbers bounce around like crazy, as well as where you would find them. For us, we always, I'm a geographer. I was born with a map in my hand, and if I can't map it, I'm probably not interested in it. And so high level stuff we tend to avoid. If we cannot give you an estimate for a very small area, then it typically doesn't really interest us enough to do it. I have not seen any really good comprehensive statistics. As I say, it tends to be local municipalities who are particularly concerned with it will do that. But I don't know of anything overall that does a good job of it. Maybe somebody else does.
Okay. Jeff, a question for you about local data. What kinds of people want to contribute or add local data to their Zoom prospector tool? What formats? Like, how do they share that?
Can pretty much be any format. If you're providing the data to us, it could be a shapefile, a geodatabase. It could be, technically, if it's a point data, it could really just be a spreadsheet with an address. With that, we can actually geocode it and turn it into a layer. KML files as well. And then dynamically, that would be with the Arcgis server. We can connect to that. So it really, typically I don't have an issue when a client will say, I'm going to have my folks send you our GIS data. I rarely get a format of something that I can't choose, so I wouldn't worry too much about that. The most standard file would be a shapefile. It's kind of the most universally interchangeable file, so that one's always good, but we can really dig into anything that the client's providing.
Thanks. Okay, and then someone's asked a question. Paul, when you were sharing your screen, it was a very small image, I guess is how it got shared. Would you be able to share your slide deck with us so I can include that in the follow-up email to registrants?
Yeah, no problem, of course.
That would be great. In fact, all of you, if you don't mind sharing your slides, I can include that so we can see them. I recognize this has taken us to the end of the hour that we have together, and so I don't know if you had any other comments, any of you, or questions for each other, anything that you would like to say in summary as we look at these different data sets and how they can all come together.
No, I'll just say, thank you for, attending, and, we always love a challenge. So if you have something that you don't think will work or that we didn't cover in here, always, let us know, because we're always innovating and excited to try new things on that. So as you can see, we've pretty much worked with whatever we have been given in the past.
Excellent. Okay. Great, thank you. Well, I want to thank everyone who's taken time out of their busy days to join us for this presentation. I really want to thank our guest presenters for taking the time to put all this information together and then to share it with you. Gary, Pankaj, Paul, Jeff, thank you all very, very much. We appreciate it. We're so delighted to be able to work with the companies you represent, and we look forward to continuing the conversation.
Thank you, guys.
Thank you.
Thank you, Lisa. Bye.
Thanks. Have a good day. Take care. Bye-bye.
Bye-bye.